Hello guys, welcome to our class for today. Today we are going to be looking at types of radioactivity. Types of radioactivity. Okay, so this is your online physics tutorial and this is my science tutors online. My name is Otobo Michael. If you are just visiting this channel, this is your online physics tutorial and we welcome you to our channel. Please, if you have not subscribed, please click on the subscribe button. Click on the notification bell so that whenever we upload a new video, YouTube will notify you. Give us a like, give us a thumbs up if you like what we are doing. We have covered a lot in physics, and these are almost like the last topics in physics. Basically, we are in atomic physics, and we have treated some topics already in this particular area of physics, right? So please invite your friends to come and enjoy what you are enjoying. Get your writing materials ready so that we can go straight to the class for today. If you have any challenge, you can reach us through the WhatsApp number that is showing right on your screen. Okay, guys, so please, today we are looking at types of radioactivity, uses of radioactivity, the health hazard and safety precaution that you need to take when handling radioactive materials. Okay, so if you are ready, please let's go straight to the class. So basically, there are two types of radioactivity. We have the natural radioactivity and artificial radioactivity. So natural radioactivity is the spontaneous decay or disintegration of the nucleus of an atom, during which alpha, beta, and gamma particles, or a combination of any two or all of them, are released plus heat energy. Okay, so natural radioactivity is not affected by external factors like pressure, temperature, and uh, chemical reactions. No, it's a spontaneous disintegration of the nucleus of an atom. So that is natural radioactivity. Then artificial radioactivity is achieved by bombarding an ordinary material with a radioactive particle to give radioactive elements, radiation, and energy. Okay, so this is a typical example of it. Aluminium is non-radioactive, but when it is bombarded with helium, which is an alpha particle, it produces a radioactive phosphorus, and then when this radioactive phosphorus is bombarded with neutron, it will give you a stable silicon, and an electron is released plus energy. Okay, so when aluminum is bombarded with helium alpha particle, it gives rise to unstable phosphorus nuclei, which is radioactive phosphorus. This now will disintegrate further spontaneously to yield silicon atom, which is stable. So this is a typical example of artificial radioactivity. So if you look at this example, you see that the neutrons, the protons, and alpha particles are used as very effective bombarding particles for disintegration. They are used as very useful particles for disintegration of nuclear elements. So if you look at this now, this is a lithium. So when a neutron is used to bombard a lithium, you will have you have hydrogen and then an alpha particle plus energy that is yielded. Then when an alpha particle is used to bombard beryllium, you will have carbon and then a neutron and an energy that is released. So all these are examples of artificial radioactivity. Okay, these are examples of artificial radioactivity. Now if you look at all this equation, you find out that the mass number on the left, they are equal to the mass number on the right. The proton number on the left, they are equal to the proton number on the right. Please take note of these equations of artificial radioactivity. Okay, so if you look at these two equations, the mass number on the left equals to mass number on the right. Mass number on the right equals to mass number on the left. Proton number on the left equals to proton number on the right. Okay, so I'm going to look at another aspect of radioactivity, and that is radioisotopes. So radioisotopes are isotopes made artificially by bombarding neutrons or protons or deuterons at elements. Okay, so the use of radioisotopes are one, they are used in medicine as radiotherapy. They are used in industries to detect faults, to detect, they are used to study defects in metals and welded joints. They are used in agriculture as radioactive tracers and preservatives, and in geological research for radio dating. So these are the major uses of radioisotopes. But what of the use of radioactivity? Uses of radioactivity. So just as we mentioned for radioisotope, the same thing, radioactivity, radioactivity the uses are many, and so we'll look at some of them. Radioactivity is used to detect leakages in underground pipes in the industry. Okay, the radioactivity or radioactive uh, material are used as tracers in agriculture to monitor water passages through plants. Radioactivity is used in medicine to locate brain tumor or blocked kidney. Radioactivity is used for sterilization of medical equipment. It is used for preservation of food. It is used for treating cancer and malignant growths like tumor in the body. It is used to detect broken bone or metal object hidden in the body. It is used to detect flaws or cracks at welding joint or engine blocks. It is used for carbon dating to study ages of archaeological discoveries. So these are some of the uses of radioactivity. Now, you can see that radioactivity is very useful, and it is just where the world is going towards. Yes, discovery of radioactivity and radioactive elements and their uses. Okay, so even though they are very useful, they still have their health effects. So what are some of the health hazards, and what are the safety precautions that can be taken to handle them safely? Health hazards of radioactive radiation and safety precautions. One of the health hazards is that overexposure to radiation can cause skin disease or destroy organs in the body. That is true. It can cause damage to human genes, genetic mutation. It can lead to leukemia, which is cancer of the blood. So, with this in mind, there are precautions that are put in place to handle radioactive substances. One, a thick lead concrete block should be used to shield workers in the industry. Okay, so if you use any material and you are working in an environment where there are radioactive or radiation is taking place, it can have a lasting effect on our bodies. The dose of radiation absorbed by patients should be controlled. So patients should not be exposed to overdose of radiation. Radiological workers should wear film sensitive to radiation as badges. Okay, so it is not good that we are exposed to too much of radiation, because they have very, very dangerous health effects. They are very dangerous health effects. Okay, guys, so this is basically where we are ending this particular class, a very brief and short one, and direct to the points. So thank you for your time, and we hope to see you in our next class. But before then, please subscribe to our channel, give us a like, give us a thumbs up, and give us positive comments. Share our videos with your friends. Is that okay? On different or different social media platforms. Thank you, and we hope to see you next time. Thanks, and have a nice day.